Hello everyone, welcome back to the channel. In today's video, we are going to understand microservices fundamentals from scratch. If you are preparing for any interview like software engineer, senior engineer, tech lead role or solution architect interviews, then this video is for you. By end of this session, you will understand what microservices are, why they were introduced, how a microservices architecture works, how different services communicate, why every service has its own database, what technology are commonly used, the advantages and the challenges of the services. So stay tuned, let's begin. Let's first understand the meaning of the word microservice. A microservice is a small independent application that is responsible only for a single business capabilities. It means one service deals with the one type of job, right? Let's think of an e-commerce application. Instead of creating one huge application that manage user, products, order, payment, inventory, shipping, and notification, we can divide the whole application into the smaller services, smaller parts. Each service has one responsibility. For example, user service manage users, product service manage the products, order service handle the orders, inventory service can handle or manage the stocks, payment service deals with the processing the payments, notification service it's manage the sending the notification and SMS. Each service works independently. This is the basic idea behind the microservices. Okay. Now let's understand this diagram what you are seeing on your screen. At the very top, you have a different client. This could be a web application, mobile application, admin portal, and third party application. All these clients send a request to our backend. Very clear? But they never communicate directly with the microservices. Meaning, when you send a request to the backend, it does not directly communicate to microservice individual service directly. Instead, what happens? Every request first reach to the API gateway. Got it? Then you think that what is API gateway? Think of the API gateway as a main entrance of the shopping mall. Like when we have the shopping malls, so we do not go directly to the every shops. First, you have to enter to the main gate. That is main entrance of the shopping mall, right? The API gateway also works in the same way and it performs some several tasks. It authenticates users, it checks authorization, it routes request to the correct service, it performs request validation, it handles rate limiting, can cache frequently requested data. It also logs every incoming request. This means clients only need to know one point. The API gateway take care of the everything else. Okay. Now let's move to the center of the diagram. Here we have multiple independent services. Let's understand each one. The user service manages everything related to the user, like doing registration, login, profile detail, preferences, etc. Whatever things related to the user, it will be managed by the user service. Same way, product service like search, pricing, catalog, product details, all of these things is managed by the product service. Order service has to handle the order creation, order status, inventory service manage the stock label details, payment service process the payments and refunds, notification service send an email, SMS and push notifications. So every individual service do the single type of the job. Notice something very important. Each service has exactly one responsibility. This is called the single responsibility principle. What is called? It is called single responsibility principle. Keeping services focused, it makes easier to develop, maintain and scale. Now look below to the every service. Each one has its own database. This is the one of the most important principle of the microservices. User service has on user database, order service has on order database, payment service has on payment database, and inventory service has its own inventory database. No service directly access another service database. For example, order service should never execute SQL query against the payment service. Instead, if it needs payment information, it calls the payment service. It keeps service loosely coupled. It also allows every service to evolve independently. Now let's move to the right side of the diagram. Microservices communicate in two different ways. First is the synchronous communication. For example, REST API means directly calling the API endpoints. Second, the gRPC. These two are mainly examples of the synchronous communication. Here one service sends a request and immediately wait for a response. For example, order service calls the payment service to process the payment and it waits. So once the payment is done, it can confirm the order. Correct? The second method of the communication is asynchronous communication. It is instead of calling another service directly, here a service publishes an event. For example, when order is created, order service publishes an event to the Kafka or RabbitMQ. Inventory service consumes it. Notification service can consume it. Analytical service can consume and consumes the same event. Notice how one event can trigger multiple actions without tightly coupling service together. Did you notice how one event can trigger multiple actions without tightly coupling service together? This is called event driven architecture. Now let's look at the bottom middle section. Point number 6, cross cutting concerns. These are the platform services. Centralized logging. Logging help us to understand what happened. Monitoring and metrics, which help us to monitor the system performance. Distributed tracing allow us to track a request across multiple services. Configuration management stores centralized configuration. Health checks tells Kubernetes whether service is healthy or not. Circuit breaker prevent cascading failures. Retries helps recover from temporary failure. Timeouts prevents Timeouts prevent requests from waiting forever. Rate limiting protects rate limiting Rate limiting protects services from excessive traffic. Security protects communication between services. These are the platform capabilities shared across all the services. Now let's move to the next point. Point number 7, deployment and infrastructure. Developer writes the code. The code is stored in the Git repository. CI/CD pipeline automatically builds the application. Docker packages the application into the container, and Kubernetes or Amazon ECS runs these containers. Cloud platform like AWS hosts the entire application. Each service can be deployed independently. This is one of the biggest advantages of the microservice. Now let's move to the next point. Key principles. Here we'll try to summarize most of the features. One service equal to the one business capability. It has database per service. Means every service has its own database. These are the loosely coupled. They communicate via APIs or events. We can independently deploy it and scale it. These are fault isolation. If something happened in one service, it doesn't mean it will happen. It doesn't happen in another service as well. No. We need to fix that service only. Automation, easily deployable every service. Easily we can monitor the each service individually, and it has the security should be implemented from the beginning. Okay. Now let's discuss the benefits of this architectural style. First benefit is faster deployment, faster development, independent release. Third one is the technology flexibility. Fourth is scalability. Fifth is the better fault isolation, and last one is the high availability. Okay. Now at the end we'll discuss about the challenge. It doesn't mean it has the only benefits. It also has some challenges as well. What are the challenges? Instead of one application, now you have to manage dozens or even hundreds of the services, which will, right? It will introduce the network latency, correct? Distributed transaction becomes difficult. Debugging requests across the multiple services is harder, right? Deployment requires automations. Data consistency became more challenging. So remember, microservices solve scalability and organizational problem, but they also introduce operational complexity. So at the end, let's quickly recap. We learned what microservices are. We understand the overall architecture. We explained the API gateway. We learned why every service on its own database. We discussed synchronous and asynchronous communications. We explored platform services like logging, monitoring, retries, circuit breaker. Finally, we covered the major benefits and challenges. In the next video, we will be dive into the domain driven design, and learn how to decide correct boundaries for the microservices. This is one of the crucial skills for designing scalable system. Thank you for watching. If you found this video helpful, don't forget to like, share and subscribe. See you in the next session. Till then, bye bye, take care.